Welcome to you all. I am welcoming you all for the session for thermodynamics, and here we are discussing the thermodynamic system. In the previous class we have discussed the how to define a system, what are the parameters to be there, generally the particular item is called thermodynamic system. Okay, here in the previous class the types of system, thermodynamic system has been discussed. Open system and closed system, they are competed. In the third one is called isolated system. Isolating means what? We are making something to be alone, making it to alone. We will not disturb others, we will not make it to disturb. Like that here also the system is called isolated. Generally I told you the classification of system based on the transfer of energy as well as the transfer of mass, whether both happens or not. Based on that the classification has been done earlier and I have told. Here isolated system, let's take one system called as perfectly insulated, thermally insulated flask. Thermally insulated flask means we are not going to make it to energy transfer. Okay, the temperature will not be going to reduce or increase. Let's take a thermally insulated flask. Okay. The flask, generally we can fill the fluid, maybe fluid or here I am filling coffee. About 5 liters of coffee I am taking, I have filled and which has a temperature of 40 degrees Celsius in C. Then after 2 hours or 3 hours I am going to use this flask. During this period I didn't use. Now I am asking you whether there will be a mass transfer happens. That means there will be increasing of mass. That means more than 5 liters or less than 5 liters. No, the quantity will be same. So that the mass transfer is not changing. No mass transfer. Okay, the mass transfer will not be there. No mass transfer. And is there any change of energy? That means is there any change of temperature? No. Still it is 40 degrees Celsius. It goes for another 5 hours, 6 hours, like that. Generally, perfectly insulated thermal flask is not at all available in general, in ideal case, but there will be a little bit change in general. But we are having an ideal condition. Perfectly insulated means there will not be any change of energy. It means there is no energy transfer. No energy transfer. Okay. For that, thermally insulated, perfectly insulated flask, thermal flask is a very good example for isolated system. So here, no mass transfer as well as the no energy transfer. This is for the isolated system. I think I have understood this isolated system. Next we can move on to laws of thermodynamics. Laws of thermodynamics. In this class, we are going to discuss what is the laws of thermodynamics, zeroth law of thermodynamics. Let's put a TD for thermodynamics. Simple case. Zeroth law of thermodynamics. Let's have a system 1. Let's take a system is called A, another system is called B, another system is called C. So I have taken 3 systems. Now let's take the system of system A has a temperature of 50 degrees Celsius. Okay, I am telling that the system A is in thermally equilibrium. With the B. Okay, thermally equilibrium with the B, as well as it is thermally equilibrium with the C. Individually, this system is thermally equilibrium with the A. So, thermally equilibrium means equilibrium. The thermal means temperature we have to concentrate. So, temperatures are equal. Temperature equal. So TA equal to TB here. So here also I am telling that TB also 50 degree Celsius. And here A and C also thermally equal. So here it is also the TC. Here is also 50 degree Celsius. So indirectly I told only A, later let's with the B and the C only. A with B, A with C. So I didn't say B and C are thermally equal, but just analyze these things. A is thermally equal with the two systems individually. So the temperatures are equal to what the temperature of the system A is having. So TB is also 50 degrees Celsius, TC is also 50 degrees Celsius. Then look at TB and then TC. Both are same. So finally I can say that the system TB of B and C, B and then C also are in equal condition, because TB is equal to TC, that is also 50 degrees Celsius. So finally we can say that the three systems are mutually thermally equilibrium. Okay, three systems are under the thermally equilibrium conditions. Okay, so how the zeroth law of thermodynamics to be defined, how to be stated. So it is this should be stated with the thermally equilibrium conditions. Okay. Then we can have another thing called first law of thermodynamics, second law of thermodynamics, and also we have third law of thermodynamics also having. Okay, I think we will have another class to discuss the second law of thermodynamics and the third law of thermodynamics. More than that, thermodynamics and equilibrium, we are saying that we are having what is only thermodynamics in temperature only we are concentrating. Is there any other equilibrium conditions, equilibrium which means other than thermally? Yes, chemical thermal equilibrium conditions. Okay, mechanical equilibrium conditions. Mechanical equilibrium means which parameter we have to concentrate. So mechanical equilibrium means we have to concentrate the force at a particular point, as well as if it is equal with another point, we have to take the forces are equal, as well as chemical reaction, chemical equilibrium. Chemical equilibrium means the reactions. So there will be no reactions. Reactions does not happen at all. That is called the chemical equilibrium. Okay. So in this class we have discussed laws of thermodynamics, that is zeroth law of thermodynamics we have discussed, and what are the different types of equilibrium. Okay. So we will have another session in the next class. Okay, thank you.